The next important LAN networking protocol is the Spanning Tree Protocol or STP. STP is a layer protocol that runs on bridges and switches. While bridges are rarely in use anymore, switches are used extensively in local area networks, and most all layer 2 networks have a spanning tree enabled by default. In this topic, we will begin with a discussion of how redundant links update their MAC address table and resolve issues with the loop formation. We will then look at the importance of STP in redundant network. Sorry. We will also look at enhancement of STP and various type of STP. And at the end, we will look at a sample log entry that the security analyst or any kind of analyst can use to help identify correlate attack on the network that might affect spanning tree. Study the diagram show here that shows a simple portion of data network. The two hosts can communicate between each other by single packet between the two switches. Let's say host B sends a ping to host A. Now assume that there are many more hosts connected to switch A and many more hosts connected to switch B, and that the network architect want to increase the bandwidth and fault tolerance between the two switches. This should be achieved by adding one more cable between the switch. In this example, a cable is added between the two switches on ports Gigabit Ethernet 1/24. Notice how adding this cable created a single layer 2 loop comprised of two switches, two cables and 4 ports total. Layer 2 loops can be larger or smaller and create the benefit of fault tolerance, failover and additional bandwidth. But watch how they create a new problem. Initially in this example, let's assume that spanning tree is not present. So what happens if any computer like host B out even one frames that directed broadcast or multicast frame, assuming all ports on both switches are in the same VLAN. Switch B forward the broadcast to all ports connected to the switch. The router will not forward the packet as layer 3 router don't forward broadcast frame by default. The outside network on different router interface will not be affected at all. Switch A receive the packet and then forward the packet to all ports for the active interface. Host A will receive the broadcast, which is initially not a problem. However, note that switch A is sending back the same packets to switch B. Switch B will then send the same packet back to switch A, and the process repeats itself over and over, on and on very quickly. This creates a broadcast storm, which is a major problem for any layer 2 switch network. The entire LAN will become literally unusable as the switches will waste all their time sending the packet around in a loop over and over without the capacity to forward and productive traffic. This problem was recognized decades ago when bridges was first created. The first solution created to solve this problem is the spanning tree protocol, which locates the loops and stop the loops. Spanning tree even has the capacity to find loops within loops. If they exist in the LAN topology, the spanning tree protocol was originally developed by DEC, Digital Equipment Corporation, a key Ethernet vendor at that time, to preserve the benefit of loop while eliminating their problem. Digital's algorithm later was revised by IEEE 802 committee and was published in the IEEE 802.1d specification. The protocol that spanning tree use is called a Bridge Protocol Data Unit or BPDU. The word bridge in the name is still used, even though BPDU used today run almost exclusively on switches. All switches sense BPDU every 2 seconds on all their ports, and all the switches work together to allocate all loops and stop all loops. To prevent loop in a network, first a reference point is needed, which is called a root bridge. A root bridge is the logical center of the spanning tree topology and is elected by STP. In this example, the elected root bridge is a switch A. Therefore, all ports on switch A will be in the forwarding state. All paths that are not needed to reach the root bridge from anywhere in the network are placed in STP block mode. In this example, note only one port is needed to stop the loop. The spanning tree protocol calculations occur when the bridge is powered up and whenever a topology change is detected. The calculation requires communication between the spanning tree bridges, which is accomplished by using the BPDUs. The spanning tree protocol designate a loop-free subset of the network's topology by placing those bridge ports that, if active, would create loops in standby blocking condition. Blocking bridge ports can be activated in the event of a primary link failure, providing a new path through the network. Note, if a cable is removed, there no longer is a loop, so spanning tree will not block any ports. Since the original 802.1d specification, many enhancements have been added. Some are implemented to speed up performance, such as uplink fast, backbone fast, and port fast, while there are configured to increase security, such as BPDU guard, BPDU filter, root guard, and loop guard. There are also other mechanisms and are not directly related to STP but can be used to complement STP operations like UDLD. Today there are various flavors of STP, such as IEEE specification of 802.1q common STP, 802.1w rapid STP, 802.1s for multiple STP are the proprietary vendor extensions. As a security analyst with suspicion can be determined by looking at this log information. This log entry show a MAC flap notification message with the MAC address in VLAN 10 flapping. 10 flapping between port gigabit 1/1 and port gigabit 1/2 on the switch. There could be various reasons for this event being triggered. For example, if there is an attacker on port gigabit 1/2 trying to spoof the MAC address of the host on gigabit 1/1, then there is a possibility that the switch generated the log message. It isn't always an attack which could trigger this kind of event though. Sometime in network with redundant link due to misconfiguration or interface flap, STP might toggle a redundant links which also could have caused the MAC address flap. In this scenario, a security analyst could use their knowledge of STP, analyze the log information, and identify whether it's a valid attack or some other type of network issue. Overall, a security analyst can narrow down the issue a lot faster with the proper understanding of the protocol and network devices, which can save time while identifying or correlating attack on the network infrastructure.